Okay, my name is Kaidi Chu. I'm a program manager at Homeland Security. A couple years ago when the Fukushima nuclear power plant exploded and the Japanese government sent humans to spray water into the containment, I got curious. I asked them, why did you send real people in there? You're the leader in robotics. So they said, we have robots, but we don't have the right robots. And last year, when we had this Boston bombing, we encountered a similar situation. We have robots that have two clamps. But what we really need is a robot with a clamp, the other arm with a scissor. So when all the backpack left behind, we don't know if they are there for to kill the first responders. So we need something to pick them up, open up real fast, but we just don't have it. The thing is, we never know what we need until we get there at the disaster situation. We may need robots with 8 legs that can climb through rubbles. We may need a robot that can fly over a flooded area, drop insulin or AED onto a patient. We may need a robot that can snake through a 6-inch pipe. We just don't know what we need until we need them. Robotic Research is a company that we hire through the Small Business Innovative Research funding, and they're building these, doing research and building these 3D printed robots for us, and also they are collecting massive database for us so we can use in the future. When we need these robots, we can print them when we need them.
My name is Alberto Lacaz. I'm the president of Robotic Research. We have been asked by the Department of Homeland Security to create a system that is capable of generating simple robots that can perform a lot of different missions. We try to condense what are the different elements that these different robots the Department of Homeland Security is using, and pick those devices and build a world around them, if you will, that is all 3D printed.
We try not to tell them how to do the job. We tell them what we need, the situations. For example, in 2 weeks, I'm going to meet with our Border Patrol, and they will tell us what kind of robot they will be needing in their work situation. And then we will convey those needs to Robotic Research, and then they will come up with new ideas, new designs, and and even better than what we imagined. So we try not to tell them how to do things, but we let them know our needs.
So for example, if you, we have a small robot, we call this Tosser. Tosser, for example, can come with 5-10 different wheels. Some wheels are better for carpet, some of them are better for gravel.
For sensors, there is really no limit as long as the payload can take it. IR, UV, LiDAR, SAR, the synthetic aperture radar, visual. So any kinds of sensors, can bio, nuke, explosive. So anything that a robot can carry, we can put them on. And because we have this standard interface that can talk to the sensors. GPS, radio, control board is down there. And it has a similar control board, LED camera, wheels, and same kind of motor we're using. So standard parts is very important.
Well, this machine, which is one of the many printers that can be used, it can generate just using standard plastic, which is the same plastic that you'll find in your car dashboard, for example, an infinite variety of parts. not only complete systems like this one here, but actually if this guy here is dropped maybe from a very large height, maybe cracks a particular piece, you can actually print the replacement part on site. The beauty of the concept of this library is that anyone in the world can submit a design, and within a few hours we can actually have the device printed or being used by Homeland Security for whatever emergency they might have at the moment. The submission website is www.nugenis.com.